Hi, and welcome to this tutorial on how to draw a grid using the module called pygame. I already have written a class that allows for drawing a line. So if you'd like to see about the code for this class, or if you'd like to learn about the code for this class, I recommend looking at the previous video. I also have a class for drawing a rectangle. We will not be using that class. I also have a class for making a game, which allows for essentially displaying a user interface with the help of this code. At the bottom here, the game is a global variable. I also have a function for testing out the line and rectangle classes. So let's go ahead and get started. We are going to make a new class called grid, and I'm going to put that class right below the line class. Eventually, I will put these classes into different files, but for now, I'm just going to leave the code as is in just one single file. I'm going to open up that class just to see what the notation is so that we don't miss anything. Let's make an initializer with the keyword self. And so far, I don't know what I'm going to put in this initializer. So I'm just going to put the keyword pass, which just allows for doing nothing. And this will allow us to make a grid object, which is an instance of this grid class. I would like all of the cells, one could say, of the grid to be a square, like each cell of the grid to be a square. So we need to think about a way to do that. And the user isn't going to know ahead of time how many columns there should be or how many rows there should be. It's going to depend on the screen size, and it would be best for this class to be able to compute the to make the grid without user input. So a grid will have a number of rows and it will have a number of columns, and the grid will have a width. So what I could say here is column width, and I can set this equal to none. And then in the initializer, we can perhaps call a function that sets this property equal to some value. So let's make a function called compute column width. And then we will also, I'm going to say pass, and then we also want to set the column width, set column width and pass. We also want to set the row width. And the row width is basically the width of each square in the grid. All right. So now we want to compute the column width, and then we will end up setting the column width and setting the row width based on whatever is computed here. I should probably just call this compute width, and then I can make this a little bit more general and just call it width. And we know, actually, it's a little too vague for me. So column width is none, and then we can just have another variable or property called row width. All right. And then I'll just call this column width. I'm just going back and forth on the names, sorry. And we'll just compute the column width. And I guess we could specify the number of columns, but not the number of rows. The number of columns can be used to, give us a starting point of how fine or coarse the grid is going to be. So we could say number of columns equals none. And number of columns is user-friendly enough to put that into the initializer. So I can now say self dot number columns equals number of columns. I think the user should be able to specify the grid, the number of columns in the grid. So we have that capability now. We also, okay, so now let's work on this function. We need to be able to access the size of the window, and we actually have done that already. But in this line here, we did that with this call. So I'm going to copy and paste that here, and we'll need to store the result in a variable called window width. So the window is the user interface that appears from pygame and the code that has been written. This returns a tuple, so I have put square brackets and a 0 here to indicate that we want the width and not the height of the window. The first argument is the width and the second is the height. So let's just make sure this is the correct notation. We have pygame.display.getWindow size and 0. Okay. So what happens when we divide window width by self dot number of columns? Think about it. If you have, say, a window width of 5 and you want 5 columns, if you do 5 divided by 5, then you'll end up with 1, and that would be the width of a single column. So we can say self dot column width is equal to this quantity here. And then we can go ahead and assign the row width as well to the column width. However, I'm doing this in the wrong function because I have these two functions here. So I'm going to copy and paste these lines of code into the corresponding functions. And I need to return this value, actually. And then I need to call this function because that gives us the width of a column. And I realize that this is not necessarily the best because it's possible that the column width has not been set to a value that's not equal to none by the time this function is called. So I'm just going to go ahead and directly call this compute column width function, which convinces me to just call this compute width. I can just say maybe a square. Square width is maybe a better name. Square width. Okay, so we now have the ability to compute the width based on the number of columns that the user passes. And actually, since the column width and the row width are the same, instead of doing column and row separately, I can just do this square width. And instead of column width, I can just make a property that's equal to square width and remove this function. All right, so that's a lot cleaner. Like the way this is looking so far. Let's save, give it a run to see if there are any errors appearing. Square width is not defined. Oh, that's because it's set square width. Oh, you know what? It's because I forgot self, the self keyword. These are methods, not functions. Well, they are functions, but they're methods. Still square width is not defined. This is in line 22. Oh goodness, I forgot none here. That's fantastic. Okay, hopefully this works. Okay, right now I have some things appearing on the screen just because of the draw shapes function that I'm calling over here. I can remove the code or comment it out so that nothing appears on our screen. I'm going to press the X. And now run. What is it saying here? Indentation error. I need to put a pass. So there's nothing happening in this code. All right. Now we just have a blank user interface. Okay, so I'm going to exit out of that, save, and we are good to proceed with the creation of the grid. So what is a grid? A grid consists of lines that are spaced, and we have computed those spaces. I believe one way to draw these lines is to start by drawing the vertical lines and then draw the horizontal lines. And when we're drawing the vertical lines, we could either draw the leftmost line or the rightmost line of a given square. But I think I'm more accustomed to drawing the rightmost line. And then when drawing the horizontal lines, I'm more accustomed to drawing the bottommost line. So then when a vertical line intersects a horizontal line, then the bottom right corner is going to represent a coordinate with respect to the origin. So for just a second, let's think about the coordinate system of this screen that pops up. The left line here corresponds to x equals 0, meaning that this line up here is the x-axis. So when you get all the way to this left corner, you're at x equals 0, and over here you're at the width of the screen, or x equals the width of the screen. And then over here we have y equals 0, and then increasing y in this direction and decreasing y in this direction. So remember, x is pointing to the right, and positive x is pointing to the right, and positive y is pointing down. So that is the way this is set up. And now we can proceed. So now that we know the width of each square, we can utilize our line class to draw a line where necessary. A logical starting point for this is to make a function called draw vertical lines. And we'll say pass for now, and then we'll also have a function for drawing the horizontal lines, not just one line, but several, say pass. And then finally, we'll have a function that draws the grid. So I could say draw grid, for example. And this will call the functions draw vertical lines and draw horizontal lines. So the question becomes, where should we draw the vertical lines and where should we draw the horizontal lines? We know how to draw a line, but it's not necessarily vertical or horizontal. So actually, we will want to have another function for drawing a just one vertical line, and we'll utilize our general draw line function, which may need to be modified to take in some input arguments. So we could modify the line function directly to have its own draw vertical line function. So I'm debating whether to put the vertical line functionality in the line class or in the grid class. I think it makes more sense to put it in the line class. And there's less code here anyway, so it's maybe nice to spread out the code a little bit. So we have, oops, that was the draw vertical lines. Okay, we want, this is just maybe an arbitrary line, and this will be a vertical line, draw vertical line, which may depend on draw line. Let's say pass, and then we will have draw horizontal line, self, and also say pass. Now, when we draw a line, that depends on the screen, the color, the starting coordinate, and the ending coordinate. So now I think it is best to keep this the same, but we'll need to update the properties of the line whenever we call this function, because this drawing functionality is based on those properties. And I kind of want to keep the function the way it's written. I don't want to pass in arguments. It makes sense that a line has a starting coordinate and an ending coordinate. So I'm going to keep those properties as is, so, or as they are. So the first thing we'll need to do is update the properties. So self dot starting coordinate equals something, and then self dot ending coordinate equals something, and then we'll do the same thing for the horizontal line function. So now it's just a matter of determining what those coordinates are. And they'll be in this kind of this form with parentheses, so might as well put that here. And we'll need a comma in between each of these parentheses. And when I say vertical line, I'm assuming it starts at the top of the screen and goes to the bottom of the screen. Technically, it doesn't matter the order. It could have gone from the bottom to the top, but I would prefer to start from the top and go to the bottom because that's slightly easier for me to think about. So since the top of the screen has the x-axis, so increasing x is from the left corner to the top right corner, we can have a varying x coordinate as a input. So we could say x coordinate, and the x coordinate will change depending on where we want to draw the vertical line, but the y, but it will stay fixed for a given line, right? And then the y coordinate for a given vertical line is going to go from 0 to the bottom of the screen, which will be the height of the screen. So we can just copy this and change the 0 to 1. So this gives us the height of the screen, pygame.display.get window size, and the second coordinate or second argument that this function returns. Then we'll want to call this function self.drawLine. Don't need any arguments here because we're setting the properties that we want to set here. I'm not going to bother setting the color or altering the game screen. I'm not sure why anyone would want to do that. And we'll need to do the same thing in this function as well. So the x coordinate is an input to the draw vertical line function. The draw horizontal line function will have an input of a y coordinate. So it's kind of the opposite. Y coordinate is going to be here. So if you can imagine drawing a bunch of horizontal lines, the y coordinate is going, or a single horizontal line, the y coordinate is going to stay the same, but the x coordinate is going to change. So when you're drawing a horizontal line, you can think of starting from the left to where x is equal to 0, and then going all the way to the width of the screen. So I can just copy and paste this, and I don't need to change the number in square brackets. So that gives us the width, and then that should draw a line on the screen. And the previous lines, if we draw a bunch of lines, the previous lines are not going to vanish because the window in Pygame doesn't remove the history of objects that are drawn, as you actually saw earlier when I was testing out some of the functions of the line class and the rectangle class. Okay, so now let's assume that our draw vertical line and draw horizontal line functions can work as intended. And we can just call it once here to test it out. Let's just test it out. Draw a vertical line. And we'll need to make a line object. So we don't need let. That's for Swift. We just can say vertical line equals line. And then we can say vertical line, draw a vertical line. We can do the same thing for this function, except horizontal line equals line. I forgot to make this uppercase. Sorry about that. And then we can call the corresponding function. Horizontal line dot draw horizontal line. All right. We're not going to implement this function yet. But it will involve calling the draw vertical lines function and the draw horizontal lines function. Actually, we can just implement it right now. We can say self dot draw vertical lines, plural, and then we'll draw the horizontal lines. Horizontal lines. Okay. So let's make a grid object. Grid equals grid to test this out. I remove this code, remove the pass, and we can call grid dot draw vertical lines, and then grid dot draw horizontal lines. So I'm testing out two things at the same time. Keep in mind though that this is really just testing out this function, and this function is just testing out this function. So we're only expecting to see two lines on the screen, a horizontal line and a vertical line. Let's see what we get. We actually messed up here with the number of columns. Looks like I forgot to specify how many columns are in the grid. Say there are 5. That will determine the spacing of the lines once we have more than one line. Or even when we only have one line, it will still impact the program. Okay, now we forgot X coordinate in line 45. Okay, right, because I did specify that. So let's set the coordinate of our vertical line and horizontal line. So we can say width equals self dot square. Let's make a get function because we might need this later on if we're going to use this as a plotting program. So get square width. We can say return self dot square width. All right, save that. And now we can just call that function. We can say square, or we can just say X position. So we'll be drawing vertical lines across the top, which is where the X axis is. X position equals self dot get square width. And then this X position can update, and then we can draw vertical lines at different X positions, and we can do the same thing for the horizontal lines function, the draw horizontal lines function, called self dot get square width. So this should be the bottom of the first square in the grid. And yeah, and then this should be the rightmost. This line should be drawn as the rightmost line of the first square in the grid. Simple as that. So now we can pass the X position argument to the draw vertical line function. We don't need to pass self. That's really this instance object that's taking care of that. Self keyword up there. It's being passed into the function. All right, so now we just need to pass in the y position to our draw horizontal line function. Okay. Let's see how this goes now. Invalid start position argument. Oh, that's not something I was expecting at all. So where is this error occurring? It's not liking the draw line in line 15. Interesting. Maybe it's the type that is not appreciated. I'm guessing because it's a float, maybe it needs to be an integer. So we can maybe force the the width to be an integer. This gets a little bit complicated when the screen width itself is not an integer. Then you have to decide what to do when, say, the screen is 100, 801 instead of 800. So we could cast everything as an integer, or I can just make the grid so this is already, so if it is a type issue, then I would just need to cast. Wondering if that's the correct thing to do in this situation. Maybe. Let's see what happens if I try to cast this quantity as an integer. Okay. I'm going to start. I think it's still complaining. So let's print out what the starting position is in our draw line function. So, oh, right, because I don't think I'm updating. No, I am, because I'm updating here. We can print out before drawing, can intercept what these values are by printing them out and start to get a sense of what's going on. If they're reasonable numbers, then it's probably a type issue. Okay. The numbers are none and 600, so it's very clear what's happening here. The x coordinate is not getting updated. Interesting. But the y coordinate is. How did the y get updated without the x? Well, okay. First we're calling draw. What are we calling? First we're calling draw vertical lines. Okay. So this this line that's being printed is from the draw vertical lines function. So the x coordinate is none. And I thought we were not passing none to the draw vertical line function. So apparently this is none. Why is that? So apparently this get square width is none, probably because we're not setting the square width. I'm going to remove this integer part and see if it still works. And then in the initializer, we're going to want to set square width. Of course, we need to do that. But before we set the square width, we need to compute it, but we are computing it when we are setting it. So that's okay. Is there anything else we need to do before we call set square width? Set square width depends on compute square width, and compute square width depends on the window size, which has already been set, and the number of columns, which has been passed in and set in the initializer. So this should take care of the problem, assuming there aren't any type issues. Compute square width is not defined. What? Did I not say? Let's try that again. Okay, name compute square width is not defined. Maybe because I need to say self. Is that really the issue here? Yeah, I needed to put self. Okay, so now we have, I was printing a lot of things, so that's obnoxious over there in the terminal, but there we have our lines, which is very satisfying. We are making good progress here. Now I'm going to exit out and I'm going to stop printing. For those of you learning that printing may actually be instructive, but I'm going to delete the print statement and continue with our grid drawing. And I just realized I've kind of just repeated our draw grid function, which draws the vertical lines and the horizontal lines. So I'm just going to say grid dot draw lines. And we also just learned that the type can be a float without any issues. See, there are actually decimal points over there. So floats are okay when drawing lines on the screen. Okay. Anyways, now we just need to loop through and draw the correct number of lines, or we draw lines until a certain condition is met, and that condition should be that we have enough screen space to draw a line, or we haven't run out of screen space, however you want to look at it. So since we're drawing the vertical lines first, we might as well handle that part first. And I'm going to do a while loop. So it's going to depend on the x position. And what should be the condition? We also want to access the screen width. That's going to be an important parameter. Might as well make that a property. So we're accessing it more than once. Window width equals none, and then we can set that in the initializer. Self dot window width equals this value here, and then we don't need that line of code. We might want to do the same thing for window height as well. And then we can say self dot window height equals this exact same thing, except we can change the number in square brackets to get that second value for the height. And I think we are good to go. I'm going to close that initializer. And actually, I don't need to close it. Okay, so now we want to draw a line when there's enough space to draw a line. When is there enough space to draw a line? Well, imagine you're drawing a bunch of vertical lines and you're getting close to the end of the screen. There's enough space to draw a line if the screen width, window width, window width minus the current X position is greater than or potentially equal to, depending on how pygame handles the situation of drawing a line when you're right on that edge case, because the line itself does have a width to it, but we'll include it just in case. Might as well draw a line if possible. And we want that to be greater than or equal to self dot square width, which we've already set, by the way, because we called this self dot set square width function. That's our property over here. So we have our condition. We're going to want to update the X position. X position equals X position plus self dot square width. And of course, we're going to want to copy and paste this code over here to allow us to instantiate a new vertical line, because that's exactly what's happening. And then we want to draw at the corresponding X position. So this is sort of our initial X. We draw it and then we update the X. Then we check if we've reached the end of the screen as far as drawing a bunch of vertical lines for a grid is concerned. All right, so this is the logic for drawing vertical lines. The logic for drawing a bunch of horizontal lines is going to be very similar. We have our Y position set already, and then we just need our while loop, while self dot window height minus Y position instead of X position is greater than or equal to self dot square width. So there's essentially enough space to draw a line. We can do what we have been doing, except it, yeah, so it's make our horizontal line and then update our Y position plus self dot square width. Okay, I'm gonna save that, and hopefully this draws our grid with 5, what did we call it? 5 columns, and we'll have more than 5 rows because we're drawing a grid with a bunch of squares and not rectangles. So let's see if this works. We're calling, I think our code is complete. We said draw vertical lines. Ooh, this horizontal lines should be draw horizontal lines. because the other function didn't exist. It was a typo. Okay. Fingers crossed that we get a grid. We got an error. Window width is not defined. I probably forgot to say self. So this is in line 42. Yeah, forgot to say self. Window width. Apparently, Python is very sensitive to that self keyword, which actually I like because then you know that you're accessing a property as opposed to maybe a parameter or a global variable. So that's actually a little bit helpful in this language. Do we get a grid? Grid object has no attribute draw lines. Where did I call draw lines? Oh geez. This is in line 121. Oops, yeah, that's supposed to be draw grid. Okay, this IDE that I'm using, I'm gonna blame the IDE. Is not helping me out. All right, so do we get a grid yet? Almost. Local variable y position referenced before assignment. Okay, line 64. Interesting. I thought I was already, I was updating that in the correct way. Y position's already set here. It doesn't like line 64. That's weird. 1 second. So I just put parentheses around the condition. Oh, I just found the problem, I think. But anyways, yeah, so I just put parentheses around each condition and that did not fix the issue. So yeah, anyways, I thought I had seen the problem, but I actually didn't. Okay, so the y positions here, the x positions are all here. I didn't mix up the x and the y. So why isn't it liking this line here? Let's try printing out. Oh, look, this is draw horizontal line. No, that's the correct thing to do. Print y position. I'll say y position. Okay, and then we'll see what y position is. Does it print anything? Hello, traceback. Not seeing anything printed. Oh, there it is. Oh, maybe I need to do self dot y position. It's literally printing out y position. It's not printing out a value, which is really, really weird. That's strange. I've never seen that before. Oh, no, wait, that's just telling me where the error is occurring. I'm going to try printing out y position before. I really want to see if the code can print out the y position. Yeah, that's weird. Well, it doesn't like line 60, which is where this y position is being set. Maybe self dot get square width isn't doing what I think. Perhaps the issue is not the y position, but it's with the self dots get square width function. Let's try that. Get square width and see what that does. Okay, so we are first drawing. It seems like the vertical lines is working, but not the horizontal lines, which is kind of interesting. Okay, well, let's see what this does, if anything. All right, so we're having a problem in line 65. Let's comment out the horizontal lines, see if we can draw the vertical lines. I'm going to take away that print statement and see what happens when I just do the vertical lines. Might have been trying to do too many things at once. Okay, so the vertical lines are okay. That's satisfying, right? We have 1, 2, 3, 4, 5 columns. But for some reason, even though I thought I was doing the exact same thing for the horizontal part, it's throwing some errors. Could it be due to the way that I'm implementing the draw horizontal line function itself? So that's up here. Oh, y coordinate. That's supposed to be a point, if I'm not mistaken. Oh, it is. Why? Hold on. I think I may have understood what's going on. Are we mixing up points and coordinates? That could be the issue. 1 second. Okay, so I don't think that was the issue. What I'm going to do is close this and see if an error message appears when I just run this as is with the horizontal lines part commented out. No error. And we see this on the screen. So when I uncomment this, we can just see where the flow goes. It's going to the draw horizontal lines function. I can comment this out and see what happens when I print y position and then self dot square width. See if that is behaving as expected. No, it is not. So that is where the problem is at least originating. So apparently y position is not defined at this print statement, which is weird because I feel like I'm defining it here. Interesting. Oh, you know what it is? It's a missing eye. That is the worst bug in the world. Oh my goodness. If you guys stuck with me through that, I applaud you. Y position. Wow. Again, I'm just gonna blame it on the IDE that didn't correct me. I need to change my IDE, literally. It's going to save me time. Okay, why position? Why position? I'm checking the spelling. Oh my goodness, postion. Wow. Okay. Position, position, postion, position. Oh dear. Wow. I need a better IDE. I'm checking the spelling. Okay. Even over here, I should probably check spelling. Okay. Wow. All right, that's coding for you. All right, and finally we have our grid. Um, Interestingly, we don't have squares over here. So for some reason, it's not doing what I want. Okay, so I'm not quite done, darn. I thought it would draw one more here, but it's not. I think that's actually because of the way I designed this. So I got a little lucky with the vertical line situation. I need this to be 0 and then move it over right away. And then I need this to start out as 0 and then move it over right away. Because I was incrementing just a little too much. I don't really want to go into the error, the reason for the error. I think it's just an error that I shouldn't have made. Okay, so I'm going to close out of here and run it. Do we get a better grid? Yes, we do. Some of it's going off the screen, but that's expected because our height is very different from our width. And if we want equal squares, that's the price we're going to have to pay, where there might be a little bit of a cutoff towards the end. So there we go. That concludes our video. I'm pretty happy with the way this turned out. Just because I want to have nicer squares, I think I'm going to change the height to equal the width. And just for funsies, I will rerun this again. And I might even show off the code a little bit by making more columns. So we have this, it looks very nice and symmetrical. Now, if we want more columns, maybe 50 columns. Let's see what that looks like. We have a grid, which is very great. Can use it for plotting. What does 50 columns look like? Wow, that's pretty awesome. Let me know in the comments if you are going to try this yourself and what you're going to use the grid for. I'd be interested in hearing various applications. All right, thanks for watching and sticking with me through all of those bugs, but I hope that was instructive for your learning of Python, because it definitely was for me. All right, I'll see you in the next video. Bye-bye.